Hi friends, hope everyone is fine. Today let us see a new topic which is instantaneous center of rotation. So in the last two classes we saw what is combined motion of translation and rotation or the general plane motion. We saw two examples also. The first example was motion of roller without slipping and the second example was a bar kept against a wall at one end and floor at the other end. We solved some problems also related to that. So that was one method of solving those problems. Now let us solve the same problems by another method. So let us explain with a figure itself. Consider a link AB. Now it has moved to a new position. This is the initial position of AB. Now it has moved to a new position A1, B1. Here the same example we have seen over there also in general plane motion. There we told it is a combined motion of translation and rotation, which means initially it will be translating and then rotating. Here we are assuming that this link has been moved from its initial position to the final position by a motion of pure rotation only. Instead of a combination of translation and rotation, we are assuming that, just assume that this link AB has been rotated from this point to this point. Now if rotation is to take place, then there should be a particular point for rotation also, about which rotation is taking place. That particular point is known as instantaneous center of rotation, and the axis passing through this point is known as instantaneous axis of rotation. So there are two terms, instantaneous center of rotation and instantaneous axis of rotation. What was instantaneous center of rotation? This link AB has been moved from its initial position to the final position just by pure motion of rotation, and it is being rotated about a certain point. That certain point is known as instantaneous center of rotation, and the axis passing through this point is known as instantaneous axis of rotation. Now let us see how to find this instantaneous center of rotation. So what we have to do is consider this link AB initial position, consider the final position A1, B1. Now don't consider these lines. So what we have to do is join this AA1. So this is the line which is joining AA1, and again join B1. So this is the line joining B1. Now draw perpendicular bisector to AA1. So this is the perpendicular bisector. We are just drawing a line which is perpendicular to AA1. So this is the perpendicular bisector. Similarly, draw a line perpendicular to BB1. So this is the perpendicular bisector to BB1. Now extend these two perpendicular bisectors, which is perpendicular to AA1 and BB1. So these are the perpendicular bisectors. Extend these lines and finally it will be meeting at a point. That particular point is known as instantaneous center of rotation. Or in other way we can say that this link AB as a whole is rotated about this instantaneous center. So what we assumed here is this link AB is rotating from this initial position to the final position about a certain point. That certain point is known as instantaneous center of rotation. That particular point is represented by, it is the letter I, that is instantaneous center of rotation. Now we can also see that this is the initial position, this is the final position. What happens if this link has been moved to another position? This is moved to another position. The instantaneous center also changes, isn't it? So as the link goes on changing its position, the instantaneous center also changes its position. Now the locus of all these instantaneous center is known as centroid, which means if the link goes on changing its position, the instantaneous center also changes its position. The locus connecting all these instantaneous center as the link goes on changing its position is called centroid. Now again we can see that this AB is undergoing pure rotation. If there is pure rotation, then there will be an angular velocity also. So let omega be the angular velocity, and as this is the link AB, let omega AB be the angular velocity of this link AB. Now assume this VA is the linear velocity at the point A, VB be the linear velocity of the point B, this VA will be perpendicular to the line connecting this instantaneous center and the point A, which means VA is perpendicular to IA and VB is perpendicular to IB. Now we can see that we are solving an equation for that. We know what is the relation between linear velocity and angular velocity. V equal to R omega. So instead of R, here it is, if you are considering this point itself, so it is VA equal to, instead of R, it is IA into omega. So linear velocity, angular velocity relation is VA equal to R omega. For this velocity at point A, it is VA equal to, instead of R, we are considering from this center of rotation to the point. So it is VA equal to IA into omega. Omega of what? This omega. This link is being rotated. So it is omega AB. So VA equal to IA into omega AB. Similarly, VB equal to IB into omega AB. So it is like this. VA equal to IA into omega AB. From that you will be getting omega AB equal to VA by IA. VB equal to IB into omega AB. So again omega AB equal to VB by IB. Here this is equation 1 and equation 2. Here we can see that omega AB is common. So equation 1 equal to equation 2, or it can be written as VA by IA equal to VB by IB. And we have also seen that this velocity is perpendicular to IA and velocity at B is perpendicular to IB. Now there are two cases to find the center of rotation, instantaneous center of rotation. Let us consider the first case. Here the velocities are parallel but unequal in magnitude. So consider there are 2 points A and B. At point A, let VA be the linear velocity. At point B, let VB be the linear velocity. Now how to find the instantaneous center? Just extend this line AB downwards. Now from point A, at the end of point A, at the end of linear velocity and at the end of linear velocity of point B, join a line and finally it will be meeting this line. That particular point is known as instantaneous center. For example, let VA equal to 10 meter per second. Let VB equal to 5 meter per second. So you will be drawing a line with 10 meter per second. VB will be less than this 10 meter per second. Let VB equal to 5 meter per second. So now you will be connecting this line from 10 to 5 and then again you will be extending it downwards. Similarly, you will be extending this line AB. Finally, it will be meeting at a point. That particular point is the instantaneous center. So there may be one more case. This case is when VA and VB is the same direction. Now there is another case when VA and VB is in the opposite direction. So how to do it? Again, we will be drawing a line from the endpoint of VA to the endpoint of VB. In between somewhere it will be meeting at this line AB. So that particular point is the instantaneous center. Now there is another case if the velocities are parallel and equal in magnitude, which means this VA and VB is equal. Let it be, so for example, let it be 10 meter per second. Both are 10 meter per second. Now, as told earlier, we will be drawing a line from the endpoints, but there is no chance of meeting these two lines, isn't it? So there won't be an instantaneous center, which means the instantaneous center for this case is infinity, or there is no instantaneous center. Again, one point to be noted is at the instantaneous center, the linear velocity will be 0. So from this examples itself, you can see it. Here there was a linear velocity. Here also there is a linear velocity. At this point I, the velocity is 0. Similarly, at this point I, the velocity is 0. So find the point where the velocity is 0. That point is the instantaneous center. Now in the syllabus it is told that just concept only is required for instantaneous center of rotation. So in order to make the concepts more clear, let us solve some problems. So okay, these problems are just the same problems what we have solved in general plane motion. So it is being done here, we will be doing it by instantaneous center of rotation. Just the method changes, the problems will be same, final answers also will be same. Let us see the first problem. A cylinder of radius 1 meter rolls without slipping along a horizontal plane AB. Its center has a uniform velocity of 20 meter per second. Find the velocities of the points D and E on the circumference of the cylinder as shown in figure. So this is the figure. This is a roller. It is being kept on a line AB. Radius is 1 meter. Now we have been asked to find the velocities at points D and E. Also, the velocity of the center point is given as 20 meter per second. So which means VC is 20 meter per second. Now what is the relation between linear velocity and angular velocity? This thing we have already seen. Will V equal to R omega, or we can say that. Before that, find the point where the velocity is 0. We already studied that at this point, the point here is O. At this point, the linear velocity is 0. If you have any doubt, just refer the first part of what we have solved in first problem, what we have solved in general plane motion. So we can see that at the point of intersection, the linear velocity will be 0, which means at this point it is 0. So that point where the linear velocity is 0 is the instantaneous center. So the linear velocity of point A is 0, it is the instantaneous center. So initially we will be locating where is the instantaneous center. Now we know that at point C, the linear velocity is 20 meter per second. Also we have the relation between linear velocity and angular velocity, V equal to R omega, or we will be saying everything in terms of this instantaneous center. So it is VC equal to OC into omega. So we know VC it is 20, OC is radius which is 1. So from that you will be getting omega which is 20 radians per second. Similarly, let us see the velocities of points D and E. So velocity of point E equal to everything we will be saying in terms of this instantaneous center. So everything to be considered from the instantaneous center. So velocity of E equal to, this will be moving in this direction towards right. So V equal to OE, this from this instantaneous center to the point considered. So it is OE into angular velocity omega. So V equal to OE into omega. What is OE? This is the diameter. So it is 1 plus 1, 2. 2 into omega is 20. So you will be getting 40 radians per second. Similarly, velocity at this point, it will be perpendicular like this. It will be going upwards. We have drawn all those things in the previous part itself in general plane motion. So velocity of D equal to, it is from this instantaneous center to the point OD into omega. So what is this OD? How to find this OD? We know this is 1 meter radius. This is also 1 meter. So OD will be root of DC square plus OC square, or it is root of 1 square plus 1 square, it is root 2. So VD equal to this OD into omega, that is root 2 into 20, you will be getting 28.28 meter per second. So I think this instantaneous center of rotation is much more simpler than the general plane motion what we have seen earlier, isn't it? In that case, we have seen how to solve all those things. Here it is simple. Just find the instantaneous center of rotation, connect that instantaneous center to the point considered, find the distance into omega. That's all for finding the linear velocity. Next problem. A compound wheel rolls without slipping as shown in figure. The velocity of center is 2 meter per second. Find the velocities of the points A and B. So the figure is given in the question itself. There are two circles. It is a compound wheel. So there are two circles. The inner circle is 0.2 meter, outer circle is 0.4 meter diameter. Center point velocity is given, we see, which is 2 meter per second. We have been asked to find the velocities at point A and B. So how to find the velocities of A and B? Initially we will be calculating the instantaneous center. Where will be the instantaneous center? It is the intersection of the roller with the ground or horizontal level. That is this point. This point, let it be O point. So O is the instantaneous center. Now how to find velocity of A point? It is from the instantaneous center to the point, that is OA into omega. Similarly, for point B, velocity of B will be OB into omega. So we should calculate this omega value. How to find omega? We have the center velocity is 2 meter per second. So V equal to R omega, or it is center point C equal to OC into omega. What is this OC distance? This diameter is 0.2, so radius will be 0.2 divided by 2, which is 0.1 meter. And this VC is also given, which is 2 meter per second. So omega equal to 20 radians per second. Similarly, VA will be equal to this OA from instantaneous center O to the point A. So it is OA into omega. How to find OA? From this C to A, it is the radius of the outer circle, which is 0.2. And from O to C, it is 0.1. So from O to A, it is 0.3 meters. So OA into omega, omega value, you know, OA value is 0.3. So you will be getting V equal to 6 meter per second. Similarly, VB equal to omega into OB. OB distance is, what will be this distance? From C to B, it is half the diameter of outer circle. That is radius, which is 0.2. From this point to this point, it is 0.1. So OB distance will be 0.2 minus 0.1, which is 0.1 itself. So it is 0.1 into omega. You will be getting 2 meter per second. Next question. A cylindrical roller is in contact at its top and bottom with two conveyor belts AB and DE as shown in figure. If the belts run at uniform speeds of 3 meter per second and 2 meter per second respectively, find the angular velocity of the roller when the velocities are in the same direction. Second case, the direction of velocities are opposite. The diameter of the roller is 40 centimeter. So this figure is given in the question itself. This is the roller. Center point is C. This is the conveyor belt AB and D. The center of the conveyor belt AB is P. Center of conveyor belt DE is Q. Now we have been asked to find the angular velocity of the roller, which means initially we will be calculating VC, linear velocity, and then the angular velocity of this roller. So this is done in a different manner. Let us see how it is done. First case is the velocities are in the same direction. As this is the point P, we can say that velocity of P equal to 3 meter per second and velocity of this Q is 2 meter per second. This is 3 meter per second and this is 2 meter per second. Now also we have a relation between linear velocity and angular velocity, which is V equal to R omega. And before that, there is one more thing. We have seen this in theory, like how to find the instantaneous center. At the top, it is 3 meter per second. That is, at point P, it is 3 meter per second. Then at Q, this diameter is 40 centimeters, so it is 0.4 meter. So at 0.4 meter, it is 2 meter per second. Velocity of Q is 2 meter per second. Now, how to find the instantaneous center? Initially, we will be calculating the instantaneous center, and based on that, we will be doing it. So what to do? We will be joining a line from this point to the end point and then extending it. Similarly, this PQ value is also extended. So finally, it will be meeting at a point I, that is the instantaneous center. This distance is known to you. PQ is the diameter, which is 0.4 meter. Let this distance from Q to I be represented by X. So now what is the velocity of P? It is Vp equal to R into omega, or it is velocity of P is here. R means it is from the instantaneous center to the point. So it is Ip into omega. What is the distance Ip? It is 0.4 plus X into omega, which is unknown. Similarly, velocity of Q will be this velocity of Q is 2 meter per second. That is equal to, again it is R omega, or it is, instead of R, it is from the instantaneous center to the point. It is Iq into omega. What is this Iq? It is X. So these are the two equations. Now equation 1 by equation 2, while solving you will be getting the value of X. So substitute in either equation 1 or 2 and find the angular velocity, which is 2.5 radians per second. Here it has been asked to find the angular velocity only. So no need to find the linear velocity, VC. If it has been asked to find the linear velocity, then just find it. That is VC equal to R into omega. Similarly, there is a second part when the velocities are in opposite direction. That is, 3 meter per second is towards right, 2 meter per second is towards left. So how to do it? Again, we will be applying the same thing. This is 3 meter per second towards right. This is 2 meter per second. This is point P. So from point P to Q, it is 0.4 meters. Then we will be drawing a line from this point to this point. In between is the intersection point is I, that is instantaneous center. So from this instantaneous center I to P, and from I to Q, we should assume some value. Let X be the distance from I to Q. So this from I to P will be 0.4 minus X. Now velocity of P will be equal to, this P will be equal to Ip into omega. What is this Ip? It is 0.4 minus X into omega is unknown. That value equal to 3. Similarly, velocity of Q equal to 2, which is IQ into omega. IQ is x into omega. So you will be getting equation 3 and equation 4. Solving equation 3 and 4, you will be getting x value. Substitute x in either equation 3 or 4 and find the angular velocity. So that was motion of roller without slipping. Now let us see the next problem, which is related to bars, which is kept on a wall at one end and the floor at the other end. So the question is, a bar PQ of length 1 meter has its ends P and Q constrained to move horizontally and vertically as shown in figure. The end P moves with constant velocity of 5 meters per second horizontally. When the bar makes an angle of 30 degrees with horizontal, find the angular velocity of the bar. Second one, the velocity of the end Q. Third one, the velocity of the midpoint M. So in this case, how to find the instantaneous center? First thing is to find the instantaneous center. So how to find the instantaneous center? Let us see. This is the question. The figure is given in the question itself. So this is the point P, this is the point Q, midpoint is M. It is making an angle 30 degree. This P is moving horizontally at 5 meters per second and Q is moving downwards. Now how to find the instantaneous center? We'll be drawing perpendiculars to these velocities. So we'll be drawing perpendicular to this and perpendicular to this velocity. So the figure will be like this, perpendicular to P, perpendicular to this velocity which is downwards. So the final meeting point is the instantaneous center. Now we have found the instantaneous center. Now we will be applying the equations, which is velocity of P equal to IP into omega. Vp equal to Ip into omega. Similarly, velocity of Q equal to Iq into omega. Let it be equation 1 and equation 2. Solving equation 1 and 2, you will be getting Vq equal to Vq by Vp equal to Iq by Ip. Iq by Ip. But from the figure, what is tan 60? Opposite side. How is it? How is this 60 degree? We know this is 30 degree. And this will be perpendicular. So the remaining will be 60 degree. So from this triangle, we can solve what is this IQ and IP. So what is tan 60? It is opposite side divided by adjacent side. That is IQ divided by IP, or we can represent this IQ divided by IP as tan 60. So VQ equal to VP into tan 60. VP, velocity of P is already known to you, which is 5 meters per second. So from that you will be getting velocity of Q point. It is 8.66 meters per second. Then just substitute in any of the equations. We have Vp equal to Ip into omega. So omega into what is this IP? Again, by solving this triangle, we can see it. If it is cos 60, we know this distance PQ. It is 1 meter. So based on that, we'll be solving it. Cos 60 is adjacent side divided by hypotenuse. So IP can be written as PQ into cos 60, where PQ value is 1 meter, cos 60 is known to you. So it is omega into PQ cos 60. So it is omega into 1 into cos 60. All these values are known to you. VP is 5. So from that you will be getting the angular velocity omega. Now there is one more part, the velocity of the midpoint M. So to find the velocity of the midpoint M, again, this is the instantaneous center. We will be drawing a line from I to M. We have velocity of midpoint M equal to Vm is Im into omega. Now how to calculate this Im? We know this PQ is 1 meter. So this M is midpoint. So PM will be 1 by 2, which is 0.5. Now from this triangle IQP, what is cos 60? We will be solving either one of the side, which means we'll be here we are finding this IP value. So what is cos 60 from this triangle, outer triangle IQP? Cos 60 is adjacent side divided by hypotenuse, which is IP divided by PQ. PQ value is known to you, so you will be getting IP is also 0.5 meter, which means this PM distance is 0.5 meter. This IP distance is also 0.5 meter. This angle is 60 degree. So what does that mean? This is an equilateral triangle. So what will be IM? IM will be also equal to this MP value as well as IP value, which is 0.5 meter. So IM equal to 0.5 meter. And what we want is the velocity of the midpoint M. So Vm equal to Im into omega. Im is 0.5 into omega value. You already got it as 10 radians per second. So you will be getting Vm equal to 5 meter per second. Let us see one more question on this one. A long rod AB is supported at the upper edge of the wall of height 2 meter and on a horizontal floor as shown in figure. The lower end of the rod moves with a horizontal velocity VA equal to 1 meter per second. Find the velocity at the contact point B of the rod and angular velocity of the rod when the rod is 60 degree to the horizontal. So this is the figure. There is AB. This is the velocity of A, it is 1 meter per second. This is the height, which is 2 meter. So this is the question. Here it is seen that beyond this B also, this ladder or this rod is extending. So what will be the velocity of this B? Instead of going vertically downwards, as there is some extension, it will be moving in this manner itself, isn't it? Till this point it will be moving in this manner itself. So this is the velocity of B and this is the velocity of A, horizontal. So the first step is to find the instantaneous center. Instantaneous center means it will be perpendicular to these two velocities. So we will be drawing a perpendicular line to VA, we will be drawing a perpendicular line to VB. So it is drawn like this and finally it will be meeting at a point I. Now this angle is 60 degree already given in the question. We will be finding the remaining angles. As this is 60 degree, this point B, we draw a horizontal line, let this point be C. So if this is 60 degree, this is also 60 degree. Now BA and IB is perpendicular, so the remaining will be 30 degree. Now by solving these triangles, you can do it. So this problem is left to you. So you can see it how it is solved. Just refer it. We are not wasting the time. Now let us see the last problem, which is on reciprocating engine mechanism. We have solved this problem over there also. So let us see how it is solved using instantaneous center of rotation. So in the reciprocating engine mechanism, the crank rotates at a uniform speed of 300 rpm in counterclockwise direction. The lengths of crank and connecting rod are 12 cm and 50 cm respectively. Find the angular velocity of the connecting rod. And the second one, the velocity of piston when the crank makes an angle of 30 degree with horizontal. So here the figure is not given in the question, so we should be remembering the figure which we draw already in general plane motion. So I told it already, sometimes the figure may be given or in some case the figure may not be given. Anyway, in this case the figure is not given, so we will be drawing the figure. So this is the figure. This is the crank, connecting rod, piston. Crank is OA, connecting rod is AB. It is making an angle 30 degree. It is moving in the counterclockwise direction or anti-clockwise direction. So all these things have been discussed in the previous part itself. So I am not going again in detail. So let us see how it is solved. So the first thing is to find the instantaneous center. Before that, we should know what is the velocity, what is the direction of velocities of each case. What will be the direction of velocity? This is OA, crank. If this is moving in anti-clockwise direction, this will be moving towards left in this direction only. So it is moving towards left, which means velocity of B will be towards left and it is horizontal. At that time, the velocity of A will be perpendicular to this OA, just like what we have seen in the previous case in general plane motion. The same thing is applied over here also. So this thing can be done like this. This is VA is perpendicular to A, VB is horizontal. So to find the instantaneous center, we will be drawing perpendiculars to this VA velocity. So it is being extended like this, which means perpendicular to the VA, we are extending this line. Similarly, perpendicular to this VB, we are extending this line. So finally, it will be meeting at a point. That point is the instantaneous center. Now let it be like that. We will see it. First, as we seen earlier, consider the motion of crank. The motion of crank only. So it is being given that it is moving at 300 rpm. So how to find the angular velocity? The relation between angular velocity and rpm is omega equal to 2 pi n by 60. So it is 2 pi into 300 by 60. You will be getting 31.4 radians per second. Then velocity of this point A will be equal to OA into omega itself. So you know the value of OA, it is 0.12 meter. Omega value, you already got it as 31.4. So you'll be getting linear velocity as 3.77 meter per second. Then the remaining step also we have solved as in general plane motion itself. So we want the value of this phi. How to find this phi? This angle is 30 degree. This phi is unknown. We have this OA distance, which is 0.12, AB distance is the connecting rod, which is 0.5 meters. So by using sine rule, it is AB divided by sine 30 equal to OA divided by sine 5. So from that you will be getting phi equal to 6.89 degree. So this motion of crank, it is same as that what we have seen in general plane motion. Nothing is different. Now let us consider the motion of the connecting rod. So again, we will be using this triangle to solve the remaining things. So we found this A, B, this is the point I, which is perpendicular to VA as well as VB. Now we want to know what are these angles. So on the angles, what we know is this is 30 degree. The velocity of A, as this is 30 degree, this will be also 30 degree, which means this VA and OA is perpendicular. So VA is making an angle 60 degree. And this phi, we got it as 6.89 degree. So if this is phi, if you are drawing a line from A, this is also phi. So this is phi, this is also phi, which is 6.89. Now as this is 30 degree, OA is making an angle 30 degree with horizontal. We are extending the same line to the instantaneous center again. So for the horizontal and this line, if this is 30 degree, this is also 30 degree. So what will be this total angle? It is 30 plus 5, which is 36.89 degree. Now again, as this is 30 degree, if you are drawing a horizontal at point A, this is 30 degree, this will be also 30 degree. And we know this is perpendicular. This point is perpendicular. So the remaining will be 60 degree. Now we got the angles. This is 60 degree, this is 36.89 degree, and let it be theta. Now how to find theta? Total is 180 degree. So it is 180 minus 60 degree minus 36.89. So you'll be getting theta equal to 83.11 degree, which means you got the angles inside this triangle: 60 degree, 36.89 degree, and 83.11 degree. We also know this connecting rod distance. So from that we should calculate this IB as well as IA distance. So how to calculate it? Using sine rule itself. From this triangle, from triangle ABI, using sine rule, it is AB divided by sine 60 equal to IB divided by 36.89 equal to IA divided by sine theta. So the angles are known to you. If you are connecting these two, you will be getting IB equal to AB into sine 36.89 divided by sine 60. So you will be getting IB equal to 0.34 meter. And similarly, connecting these two, you can connect these two also. Anyway, you will be getting IA equal to 0.57 meter. Now what we want is to find the velocity. So we have VA equal to IA into omega AB. Then VA value is already known to you, which is 3.77 meter per second. IA value, you got it as 0.57. What we want is this angular velocity omega. So omega AB, that is angular velocity of connecting rod, you will be getting it as 6.58 radians per second. Also, it has been asked to find the velocity of piston, which is B, velocity of B. It is equal to IB into omega AB. All these things we have seen in the previous problems itself, so no need to explain it too much. So IB value is 0.34, omega value, you got it as 6.58. You will be getting the velocity of piston as 2.28 meter per second. So that's all about instantaneous center of rotation. I think it is clear to you. Thank you for watching the video.